Hey guys, these notes are for day 5 in advanced algebra. They are going to cover graphing trig functions with all of the changes. So we have amplitude changes, period changes, and vertical shifts. At this point, you've seen amplitude changes and you've also seen period changes. So the newest component today is going to be a vertical shift. So as you can see right here in bold, we have y equals a times sine of b theta plus k, and then the same for cosine. So y equals a cosine b theta plus k. So the a, the b, and the k all have specific jobs. Basically, they are what change these sine and cosine graphs. As you learned in the very first lesson when we started graphing, the a out here is going to affect the amplitude. So the absolute value of that A tells us my amplitude. If there is a 2 out there, it's going to stretch it vertically by a factor of 2. If there is a negative, it reflects it across the x-axis. So this A, we would say that A is outside of the sine because sine b theta, just that part. So the B, we would call inside the sine equation, but the a and the k we would call outside, and that'll come into play later. So b is inside where a and k are outside. So a, like I was saying, is an outside number, so it changes the y values. Outside numbers change our y values. Inside numbers change our x values. So if you remember from the previous lesson, b is inside, and it's going to change the period of the graph. So it's going to stretch it. It's either going to make it, it's going to stretch it or shrink it horizontally. So a change in amplitude, this A out front, is going to stretch your graph vertically or up and down, where B is going to either compress it horizontally or stretch it. So it's going to stretch it horizontally or shrink it horizontally. So again, A is outside, B is inside. So the newest component is K. That is another outside number, and that is going to shift our graph up or down, okay? So A refers, or will change the amplitude, B will change the period, and K will change it, will shift it up and down vertically. So when we shift the graph vertically, either up or down, we're also going to shift that midline up or down. So that's what this is saying right here. When we shift vertically, the midline, which was y equals 0, also shifts up. So whatever you shift your graph up by, you shift the midline up by, or if you shift your graph down, you shift the midline down as well. So if k is greater than 0 or positive, so if this plus k at the end is positive, your graph, your shift is up. If k is negative, so if you see minus something at the end, your graph will shift down. So k is called the vertical shift. All right, so in these graphs, we are to determine the amplitude, period, vertical shift, and equation of the midline, and then graph it. So if you look here, I have the A value is 1. My B value, or inside, is 1 as well. So A and B are both 1, and then my K value is 2. So when I look back up here, my A value is 1. So I don't really have an amplitude change. My B value is 1, so I don't have a period change. The only thing we're going to look at on this graph is a vertical shift, and that's going to be up 2. So I'm going to go ahead and write that vertical shift in 2. That makes my midline y equals 2, and that will make more sense when we graph it. Now, the number out here is 1, like we said, so the amplitude is always the absolute value of your A value, or 1 in this case. And then to find the period, as you learned in the previous lesson, you take 360 degrees, which is the normal period for sine, and you divide it by the B value. Okay, well, since my B value is 1, my period is just 360 degrees. It doesn't change. All right, so if I want to start graphing this, I need to fill in my parent table. So sine of 0 is 0, sine of 90 is 1, 180 is 0, then negative 1, and back to 0. So this is my parent table for sine, and you probably have that memorized. Now, as we were saying, anything outside changes the y values. So this 2 right here changes my y values. The only thing that's going to change your theta values is a number right in here next to this theta. So since I have nothing inside, my theta values don't change from my parent table. So I have 0 degrees, 90, 180, 270, and 360. So again, those don't change because there's nothing next to that theta. Now outside numbers, so the a and the k, change my y. Well, I don't have an a other than 1. So all I'm going to do is take my y values, and I mean these y values, my parent y values, and I do whatever it says. I'm going to add 2 to that. Okay, so that's going to give me 0 plus 2 is 2, 1 plus 2 is 3, 0 plus 2 is 2, negative 1 plus 2 is 1, and 0 plus 2 is 2. So I take these y values and I add 2, and that's because of this plus 2 on the end. If I graph these, 93, 182. Now, that's only one period, and the directions say 2, so I'm going to graph backwards here. This is the start and finish of the graph. So what I'm doing is I'm going to put another copy of it here. So I'm kind of going backwards. So here, then here, now I'm going to graph here. So that will be right there, then 3, and 2. So now I just have to sketch in the curve. Probably have to turn my paper. Okay, there is my shifted sine graph. So remember, the only change was that it was shifted up 2. Otherwise, it looks just like the regular sine graph. Now, as you can see here, the middle of my graph is right there now. That used to be, the middle of my graph used to be the x-axis, or y equals 2. Well, if you picture the midline here on the x-axis, since my graph shifted up 2, so did my midline. That's why the equation of my midline is y equals 2. It will always match your vertical shift. Moving on to example number 2, we have a couple changes. Everything is outside. You can see there's nothing inside here again. What that means is my theta values don't change at all. Remember, inside here is when I start changing my theta values. Outside, so both of these changes, the negative and the -1, change my y values. So that says multiply by -1 and subtract 1. So once we get to the table, we'll write that in. Let's go ahead and go through and write out my amplitude. My a value is -1, so the amplitude is the absolute value of -1, which is 1. Since there's no number in here other than 1, the period does not change, so it is 360 degrees. My vertical shift is down 1. Therefore, my midline is y equals -1. That, again, it matches your vertical shift. My parent table for cosine is 1, 0, -1, 0, and 1. So again, that's your parent table. I'm doing nothing to my theta values. They do not change. So I have 0, 90, 180, 270, and 360. Now I have two changes to my y's. Not only do I have a -1, I now have a times -1. And you're going to basically follow order of operations. So first you're going to multiply by -1, and then you're going to subtract 1. And I'm talking about these original y values. You multiply by -1 and then subtract 1. So in other words, you're going to multiply your y values by -1 or -y, and then you're going to subtract 1. So take each y value here and plug it into this little equation right here. So 1 times -1 is -1, minus 1 is -2. Take 0. 0 times -1 is 0, minus 1 is -1. -1 times -1 is +1, minus 1 is 0. 0 times -1 is 0, minus 1 is -1. Plug in your 1 here. That's going to give you -1 minus 1, or -2. Now I just have to plot those. Again, I need to copy this here, so it's the beginning and the end, and then 270, that would go right there. That would go there, there, and there. So now I just have to sketch in my curve. Okay, so there is my cosine curve. So not only did I shift the graph down 1, I multiplied it by the negative out front, and remember the negative reflects it down. Okay, so it's reflected across, so it's kind of flipped over and shifted down 1. You'll see that's my midline is y equals -1, so we kind of got that from the equation. But now that it's graphed, hopefully you understand why the equation of the midline is y equals -1. So this graph, we had two changes. We had the reflection and the down one. Both changed my y value because they were outside of my cosine function. You'll see on example 3 that we are looking at cosine again, but we have something outside and something inside. So this right here will change my y values. And the 2 right here changes your theta values. Okay, since it changes your theta values, that's your x values. That's on your x-axis, so that changes your period as well. So the number out front here is 1, so therefore my amplitude is the absolute value 1, or 1. Now, you learned from the previous unit or the previous day's notes that you take the normal period and you're going to divide by whatever's inside here. So when we're changing out, when we have our outside changes, the negative, like on the previous one, we had the negative and the minus, whatever's outside, that's what you do to the y value. So if this says +3, I'm going to add 3. But when it's inside, you do the opposite. So it says times 2, I'm going to divide by 2. That means the period is 180 degrees. So I'm going to do that to my theta values as well. I'm going to divide by 2. And like we were saying, +3 changes the y values, and you actually do what it says. So if it says +3, you don't do the opposite. You actually add 3. The vertical shift is my 3, so therefore my midline is y equals 3. So sometimes it's easier to figure out the changes and write this little key over here for you. So what do I do to the thetas? I do the opposite. I divide by 2. What do I do to my y's? Well, there's nothing out here to multiply, so I just add 3 to my y's. Take your cosine parent table, which is 1, 0, -1, 0, and 1. And these theta and y values are what I change for this table. So take your theta values and divide them all by 2. Well, 0 divided by 2 is still 0. 90 divided by 2 is 45. 180 divided by 2 is 90. 270 divided by 2 is 135. and 360 divided by 2 is 180. So you can see 0 to 180 is going to be a whole cycle, and that makes sense because the period is 180. I just take these y values and I add 3. Super easy. Okay, so divide by 2, add 3, and now I have my table values to graph. So I'm at 0, 4, 45, which is right here. It's not marked, but we know it's between 0 and 90. So 45 is 3, 90 is 2, 135, which is right here, is 3, and 180 is 4. So you can see that that is squished significantly. So I'm going to do one other cycle of it here. So I was able to get 2 cycles just in this chunk of my graph. I can get 2 more over here. So let's sketch this in first. All right. I'm going to have to turn my paper. Okay. So there is your sketch, and this should kind of curve down more actually. That's okay. All right. It's definitely a rough sketch, but it'll work. Okay, so you can see our midline is supposed to be at y equals 3, and if I sketch in the graph or the dashed line here, y equals 3, it definitely goes right through the middle of our graph. It kind of confirms that we did this correctly. So my whole graph is shifted up 3, and then I'm condensed. So I was able to do 1, 2, 4 cycles all the way across, where normally I can do 2. So it is definitely squished, and that's because of this 2 right here. And like I said, you saw that in the previous day's lessons where you were changing the period on these functions. All right, one more example for this. We kind of have one of everything. We have an amplitude change, period change, kind of a little bit of everything, like I said. So let's go through and look here. You have 2 things outside. So you have -2 and -3. Those, again, change your y values. And you do exactly what it says. So you would multiply by -2 and then subtract 3. So if it helps, hop over here. You would do -2y minus 3. So you would multiply your y by -2 and subtract 3. And that's because those are my outside numbers, times -2 minus 3. My 1/2 theta, that changes my theta values. And remember, you do the opposite. This says multiply by 1/2, so we would divide by 1/2. Now, the tricky part is dividing by 1/2. Dividing by a fraction is ugly. So what we would do here, and I'm going to write it up here, is we would take theta and we would divide by 1/2. Well, dividing by 1/2 is yucky. It is going to look like this. I'm going to put theta over 1, and I'm going to multiply by the reciprocal because that's how I divide fractions. Well, in the end here, this just is 2 times theta. So in other words, dividing by 1/2 is the same as multiplying by 2, and there's your mathematical reason as to why. So instead of dividing by 1/2, it is much easier to multiply by 2, so that's what we are going to do. So one more time, dividing by 1/2 is the same as multiplying by 2. Dividing by 1/3 is the same as multiplying by 3. So dividing by a fraction is the same as multiplying by the denominator of that fraction. Or if the numerator is 1, remember we multiply by the reciprocal. But in this case, dividing by 1/2 is the same as multiplying by 2. So I am going to fill in these changes now. My amplitude is the absolute value of -2, which is 2. The period, I'm going to do the same thing. I would do 360 divided by 1/2. Well, that's yucky. So I'm going to take 360 and I'm going to multiply by 2. So the period is 720 degrees. So one more time, dividing by a half is the same as multiplying by 2. Your vertical shift is down 3. So your midline is y equals -3. Fill in your parent table for sign. 0, 1, 0, -1, and 0. And we've already figured out what to do. So remember the outside, you change your y. So times -2 minus 3 times -2 minus 3, and then multiply my theta values by 2. So if I go through here and multiply all these by 2, I have 0, 180, 360, 540, and 10. 720, sorry. Okay. Now my y's, I'm going to multiply by -2 and then subtract 3. So that one's going to be -3. That would be -2 minus 3, so -5. 0 times -2 is 0 minus 3. -1 times -2 is 2 minus 3 is -1. And then this guy is -3 as well. So now I just have to plot those. 0, -3, 180, -5. So this one is stretched horizontally. 360, -3. And I wasn't even able to get all of this on my graph. So that's like half of a period. Okay, so I'm going to kind of sketch this in. All right, now the end of this graph is the end of this graph as well. So basically, I'm going to go backwards, and this is going to be at -1 and -3. So what I would have done here is after the -3, I'm at this value right here, I would have gone up to -1. So let me sketch it in and then I'll... Okay. So the next graph or next point on here would have been -1 and then back to -3. So basically the end of this graph is over here. All right, so if you have any questions, you can... Oh, we didn't draw in the midline. Let's draw in the midline real fast. All right. So you can see that's at y equals -3. All right, guys, this is all of the changes on the trig graphs. If you have any questions, you can just email your advanced algebra teacher or any advanced algebra teacher, and we will hopefully be able to answer your questions. Good luck.